Thank you, and good morning or good afternoon, wherever you may be in the world. Welcome to day 2 of leg 2 of the Canyon, Seamounts and Reefs voyage of the Coral Sea and Great Barrier Marine Park. Broadcasting live from ROV Falkor. It's a Sunday morning here where we are. Beautiful day, skies are clear, seas are calm, and we've just deployed ROV SuBastian to a water depth of 1,342 metres. We're really quite excited right now because we've dropped the SuBastian right onto some rock outcrop, which we were really crossing our fingers to see, and we've got it. We can barely contain ourselves. Let me paint a bit of a picture of where we are and why we're here. So those who were online yesterday would have seen us do a dive in a submarine canyon. We got down to 1,800 metres water depth. That was at the mouth of the canyon, more or less. Today we're in that same canyon, but a bit of a different arm. It will come up slope closer to the Great Barrier Reef by a distance of about 5 kilometres. And as we've come up slope, of course it's shallower, so like I said, we're in 1,340 metres water depth. This part of the canyon, it's narrower. The sides of the canyon wall are a bit steeper. It's assumed what we call very much a V-shaped valley form. And as you can see, we're seeing direct outcrop exposure of the rocks that form this canyon wall system. Yesterday we saw a little bit of rock. Yesterday we saw mostly soft sediment plains and sediment drapes, which was fascinating, particularly from the biological point of view, with a lot of burrowing and infill. But we've changed character today in a big way, so far at least, is where we've dropped to right now. So these rocks, clearly in colour, you're looking at something which is sort of a charcoal grey to black. But as we've just been zooming around in the last few minutes, we've seen bits of the rock which are different colour there, orangey brown, you might say, slight light grey. So we're currently thinking that the black grey is most likely a sort of a manganese crust, which is very characteristic of deep ocean environments that grows on hard surfaces over geological time. But where we've got the other colour rock, that's most likely a fresh face of the rock, and we're very much interested in seeing that fresh face because it gives us insights into the true properties of the rock. Okay, here's a little bit coming into view on the left right now. There we go, orangey brown, greenish kind of colour. That's as fresh as rock face as you kind of hope to get in this environment. It's beautiful. Just move along here a little bit. There's a little bit of sand, muddy sand draping it, but it's great exposure still. Small crustacea sitting on the rock face. So we move along. Okay, that's cool. So it's very steep. So this is the other point about where we're sitting now. We're near the canyon floor, but not quite. It's on the edge of it, on its southern flank, if you like. And the track will take us across the southern flank, across the canyon floor, very narrow stretch, and then we'll climb afterwards the northern canyon wall. That's great. Okay, let's just zoom in.
Yep.
Thanks, mate. Thanks, J-Rod. Okay, and we'll just drift up to the slightly shallower view. We've got a lovely outcrop where we can help describe those rocks a bit more for those that are keen on the geology. So, and I know there's a few online that are. That is stunning from a geological perspective because we're seeing evidence of these being sedimentary rocks. Okay, great. So we'll just, now the zoom again is just, whoops. We'll just zoom into this face. Now we need.
You want to look at, or just nice slow move?
Just a nice slow move, thanks J-Rod. It would be beautiful. Just hover here, we'll take in the view. Now we need to be careful that we're separating the benthic organisms which are growing on this rock face from what the rock itself might be. So these grey sort of halo oval shaped features. Any comments from the team here? May well be biological.
Yes.
Yeah. Sponges, thank you.
Good glass sponges.
Sponges, yeah, that's great. They're growing on the rock face. Looking at bryozoans there on the right. And if we just pan down a little, so down to the bottom there, we've got, that's a fraction, yeah, thanks J-Rod, that's lovely there. Get some good, I want to zoom in a bit more.
This looks like a carnivorous sponge.
Yeah, so we're getting, yeah, that lower section there, that deep orange colour passing down into the green. So the orange will be from some degree of oxidation on the fresh faces. But there's definitely some hints of fine-grained laminar in that. Pretty disturbed, pretty contorted, wavy, broken up, I've got to say. But this is giving us outstanding insights into the underlying geology which these canyons are formed within. Be lovely to try a sample on that. So we have the ROV team have been brilliant in their support in developing on the fly a experimental tool to take a sample of the rock, perhaps to drill in. We'll try. So yeah, J-Rod, if you
want to sit down where those sponges were, we get a rock sample, and then after we can pluck off from those carnivorous sponges.
Sounds good to me.
Great, yeah, so we're going to settle the SuBastian for a while here and get the arms out, and I think we'll target that orangey brown layer just at the base of that face. See how we go. This is extremely experimental, everybody. We're really. But it's worth a shot. These are sort of outcrops you dream for.
It's an optical reef.
Yeah, I'm going to put rock on.
So while we're waiting for that, we can describe some of the biota as they appear. Jeremy's standing next to me. Introduce him for the morning. How are you this morning, Jeremy?
Oh, I'm good. I mean, it's obvious, you know, a geologist, we settle down and we both are in awe, but for very different reasons. He's looking at the rocks and talking about the color of the rocks, and I'm just looking at, you know, 6 different groups of life in one section here. We see hydroids, octocorals, carnivorous sponges, I think, and then regular sponges. So in this one rock face, there's so much here. We could basically come up after this and have enough for the rest of the day to work on. But
yep,
we've got hours.
We've got hours. We've got a full day. So just painting the picture for the day, we'll be doing 2 dives today is the game plan. This dive in the mid-reaches of the canyon.
There was a question that I'll just answer.
Sure, go for it.
So why we aren't collecting fish on this expedition? It's so when these expeditions are designed, So the people involved have specific questions to answer. And for this trip, it was the geology and specific biology. So in our case, it was sponges and corals. And no one was working on the fish that was directly involved in this project. And therefore, that's why we're not collecting fish for this expedition.
Where do you want us to?
Okay, well, let's try the orange stuff.
Look at this.
Are you on radar? Just make sure your thing is all the way.
Yes, we are also collecting plankton. Sorry, Dougal. Dougal, thanks for being here. You can help us identify some of this benthic fauna that we're seeing here.
So even if this, just have a go at this.
I'm sure. I'm sure.
Yeah.
Did you see all the stuff right next to the right? I missed that. So there's carnivorous sponges, regular sponges, bryozoans, and hydroids.
Bounce. Even if we break off some
soft coral
chips, that'd be
right here.
cool. But no, we're actually.
Look at this.
This stuff is a little bit harder than that.
Yeah, it's pretty tough. These are potentially quite old rocks.
What are these? These little polychaete? What are these?
I think they're magnetic forms.
Oh, you think those tubular?
Tubes.
I've never seen a tube like that.
Yeah, I don't think it's gonna break this one off.
Nah.
I thought we're actually in the shell.
Now, what if I did head on to the reef?
That's
So
so
that clearly proved very, very hard, that surface, which is not surprising. It's just, we're just using an adapted cutting face at the moment. Trying that on the edge.
Scratching.
Scratching is good.
Scratching is good.
Oh yeah, it is. So it's a sword.
Yes, we need our G-pick down there, I think, to house the...
Ooh.
The rock one.
Did it used to have teeth?
Better than that.
It used to have teeth. Oh, that's... Yeah, that's carbide tough.
Oh, yeah. Okay.
Carbide tips. Okay.
Alright, well, you want us to just throw this in?
Stow this here. Interesting lesson. That's good. Okay.
Yeah, we have another drill that's currently being made by our ROV team, so we thought we would try to use this one while we were waiting.
You want to try scratching some more? Like mainly by the orange?
Yeah, yeah. So we'll just wait. So we're just not quite giving up yet. We're just going to see. Just let this cloud clear for a bit. We can see what we're doing. Yeah, it'd be great just to knock off a chip, at least.
Try to scratch this area.
Yeah, comment from online there. Someone, Oak Tree, saying, I mean, this is real science, trial and error. You're dead right. We have great capability out here. We can adapt as best we can. You know, the overall objectives of the voyage are to characterise the seabed as much as we can from a geological and biological point of view. You know, we're really well equipped with sampling and observation gear, but sometimes you just got to do things on the fly a little bit. Not get your hopes up too high. Here we go, it's getting a bit of a clearer view. Exactly unknown explorer, you don't know till you try. Having another attack. It's really bouncing off that surface. You can see it's.
Yeah, just trying to scratch this one area up real good.
Yeah.
So I'll zoom in.
Yeah, thanks, J-Rod. Just trying to concentrate on one spot and maybe give it a bit of a working over, as it were. So on screen there for everybody, you can see a view of the canyon in 3D from our mapping. Last night and the night before, we mapped the canyon in its entirety in great resolution, so we can really have a clear understanding of where we are in the system. So that on screen for everyone, we've got a 3D perspective view looking into the canyon wall in the spot that we're sitting at the moment, 1,340 metres. Okay. Coming in again.
No, he said he thinks he broke something off. Let's see if it still is. There's a little sliver that broke off.
Thanks, J-Rod. With one of the ROV pilots think it might have chipped something off, so we're just trying to see if we can spot it. And even the smallest centimetre chip would be something to give us a little hand specimen to look at it under microscope. Even that's something that size reveals a lot to us.
Like come off of here, like fly around somewhere else and let this settle here.
That's a good idea. Let's, it's going to, thanks, J-Rod. Let's do that. It's clearly pretty cloudy and dirty right now, so we're just going to zoom out and move away for a few minutes and get a bit of feel for the local area. Yeah, thanks, J-Rod. We'll do that. And, yeah, and just see what else we've got. Okay, just retracting the arm for the moment.
I'll stay in this area most of it.
Yep. Okay. You never know, we may see a bit of overhang that we can... It's quite green. What's going on? Okay. Okay, we've seen that spot before. Our crustacean hasn't moved from half an hour ago. A lot of flakes in the water column there. Been kicked up. Okay. Wow, this outcrop is pretty significant when we lift our heads a bit here, and there's that fish sitting on that little ledge. Kind of nice little home there. Real estate there, looking at the top down.
Yeah, not bothered by the avalanche.
No, interesting. Yeah, hasn't been disturbed.
Oh, can we look over here?
Yeah, happy to do that.
J-Rod?
Let's zoom in on the right there. See what's growing on that rock face.
So, we saw some sponges earlier. These might also be sponges. A lot of sediment on them.
Yeah,
Maybe on the other side of the rock face.
Something big right
Right.
below me. Could just be another sponge. Just a bigger sponge.
Ooh.
If at the start, sitting on the end of it, it's like head snake.
We'll look for some jointing where there's a bedding plane.
yeah. Yeah.
This rock,
Further.
you see any just just really old, could be sedimentary with
Yeah, I think it's been metamorphosed, yeah. Getting a sense with these rocks that, given their hardness for one thing, that they could be... Yeah.
Go back over to the other area.
Did you want to try?
Well, actually, we've just realised, J-Rod, there's a bit of an overhang right here. Whether we can snap it off with the drill, just have a nibble at the edge and see what might happen.
Yeah.
Thank you. Clearly hard rocks, but we are getting a hint of some degree of structure to the rock, so whether they could be a metamorphosed sedimentary rock that extremely very old. A little bit of outcrop we've seen. There's been hints of fine grain bedding, very contorted, highly fractured too by the look of it. There's our drill bit again. Let's see what we go.
it's got, even if it's not possible to drill, I think if we find a loose rock anywhere in the vicinity, we should just grab it.
Yeah, be cool.
You want to go with that?
Yes, I think we'll take that side.
Okay, so we're going to try for this.
A little overhang. Come around again. Yeah.
I was thinking more about snapping it as well.
Like with the jaws,
Do you think the jaws would break that?
it's possible, but I mean, Cody can go and hit it and see if maybe he can knock it. Yeah, he can pick it up.
So we'll give this a.
Good Cody.
How big do you think that glass sponge is next to what we're doing?
That's breaking chips off.
Getting some flags.
There's a laser right below.
It says bitten in.
It's biting in this time, it seems.
Hey.
That's pretty neat. See what the outcome is. It's,
Pretty good.
at least you're not bouncing off as much.
I think he's definitely in a group now.
Yeah.
Oh, really good.
Wow. Okay. Cross our fingers here, everyone.
Good thing about drilling down here, you got lots of cooling.
J-Rod just joked, you know, you can drill here, plenty of cooling fluid around. Water temperature 3.4 degrees at 1,342 metres.
Boy.
Thought he maybe installed.
That's not smoke, that's just a fine grain rock flour, you might say, coming off the drill.
Smoke sounds cool.
That smoke sounds cool, says J-Rod.
I'm excited to read. I'm excited to read your methods in the publication that comes from this.
So,
Is it bending? Twisting.
yeah. That pipe looks... Is that pipe bending? The pipe's bending.
I'd say that's deep enough.
Yeah, that's great. That's just... We'll take... If anything comes of this, that would be neat.
Yeah, a piece of rock is coming out.
Oh, yeah.
I got a few of it. Might be-
Champion.
Might be.
And we're done.
We might have dropped it, but
I'm going.
J-Rod's confident.
Alright, I'm just going to the bottom where that avalanche went, just in case.
Yep.
It rolled down to there. I don't think it did. I think it actually stopped before that.
Okay.
There, here at the bottom of our avalanche.
Now we're searching for the...
It's kind
Yes, it was. A question online, was the drill developed specifically for this mission? I guess it has been. Absolutely. He says, J-Rod, we built it in the workshop here on the ship just in the last couple of days after thinking a bit about what we're seeing, what we had on board to adapt with.
Where would y'all like to stow this? In bow box 2 or 3 and 4?
1A.
No, the drill.
Oh, the drill, sorry.
Might have been a once only there.
Do you want it in 2 with the scoop or back in 3 and 4?
Pretty rough.
That is very good. Cody, bow box 3 and 4 coming up.
Just going to stow our slightly bent
Are used.
But useful.
but used and productive.
Proof of concept.
That looks like copper piping. Is that copper?
No, I think it was, no.
Okay, good. Yeah. There we go.
I don't think they would have been able to weld it.
Yeah, okay.
Yeah, that'd be good. 3 and 4 coming close.
Scott.
Just going to search around to see what we might have dropped.
I think we can go back to the spot we first drilled at. I think it's like right over here.
Right. Yeah, little avalanches going on here.
Yeah, maybe
very
it's
steep.
not. Maybe a new spot. That's all right.
See where we are? We are on the southern side.
Yeah, okay. Yeah, good.
And we're just above this one. So think of how steep this is and what that looks like there. We're going to definitely get some.
Yeah, okay. Okay.
Down to the right one. I see the flag shows you that the reef. And you come zoom in on that. See the flag here.
You're still searching?
This is where we mark.
Yeah.
So we're still having a bit of a go at trying to find that bit of rock we drilled out. We do now have a good understanding of where we are with the onboard navigation from the SuBastian, so we can position precisely the expert ROV pilots. But it's made all a bit harder with this cloudy water. So a question online about how we test the rock samples that we might collect. So we can you can do a range of things, but with these things like this, you'd make a thin section that you would polish and look at under a light microscope to look at the mineralogy based on typically colour, form of the minerals that make up in the rock face, the rock sample I should say. And that allows you to separate out minerals such as quartz from feldspar, from maybe micaceous materials. They're all the sorts of minerals you find in what we call clastic rocks, clastic being broken fragments of rock which end up in rock again as sediments. Remembering we have the rock cycle, whereby nature is constantly recycling mineral elements on the Earth's surface into sedimentary rocks over geological time periods. So if we're able to identify some of the mineral components, we can then start potentially to trace where they've come from in their history. So we're just cruising up the muddiest slope right now. This is really very steep, folks, as you can tell. Particularly with those avalanches rushing down.
I just reached out. Well,
So, should be coming up on that initial up that we were looking at.
Yeah. Okay.
Yeah, I know should be able to work on
dogs and Falkor. Like, here's where see where the US
Okay, just scanning the floor below where we cut before.
What a shame if we can't find it.
Yeah.
It's a successful drill.
was that fish?
That was right at the start, but we did move it a little bit around from the start point.
So John, should we go backwards? We're gonna head. Okay, go north. Let's go down to the bottom. Bottom up and start heading back up here to the north.
Just repositioning the SuBastian at the moment again. So the screen's gone a bit. We've just come off the seabed a little bit, so it's gone all that blue water. But there we go, coming into view again. Getting yeah, the fish was up there. Just going to be around the corner a bit.
Soft sediments is being eroded a little bit further south.
Is that the chip on the floor? I don't know. Getting my hopes up.
Oh, that's where we drilled.
There's something down.
Rock right there.
Yeah, that's. I think we got.
Oh, we drilled over there.
I'm just gonna look it up.
There's the rock.
Make sure.
Yep. J Rod's taking it carefully in here.
Someone deserves a beer after this.
We were right in here, right?
That was the drill spot.
Yeah, that's what we took.
So it was right here next to this stuff.
Yeah.
So I reckon
Right here.
Yeah. So we drilled
where that. Yeah, we can. Yeah, okay. We rediscovered our sample location precisely, and that rock has just fallen down the steep sand slope. Tell you what, the tension in here is pretty high. We're all just thinking, can we get this thing? But everyone's calm, got to say. It's made all the more harder by stirring up the mud like this.
Right here. Keeping in mind, folks, we're steering a SuBastian, which is the size of a small car. You know, we're flying along this canyon wall, rock outcrop, and then extending the arms into these precise locations. It's really phenomenal, the control we have.
So you're right there, Cody?
For me, this is the first trying to do this in my career. And I think we might have hit payload. Let the guys focus in.
Are you going to want to take a look just to be sure, or if we see that this one has like a round thing on it, good with it?
Take what?
Take it
Take it.
anyway.
Take it.
Take
Yeah.
both of them?
Yes. Yeah, if you can. Yeah. 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 Good. Yeah, that's a classed. I think it's not washing off. We'll see what it is when we get it on. That's just mud.
Might be the one next to it.
Well, the dark piece next to it is definitely the rock. So we think that's just. We have a. Yeah, that's a useful little sample of the sediment anyway. The modern sediment, I should say.
Go into A.
Yes, yeah, A would be great, thank you.
So we're taking this.
So there was a question, why not just drill another hole?
Yeah, I know, it's always a toss-up, isn't it? We have bent our drill stem as well, so I don't think it's going to turn too effectively, unfortunately. But
Be like a one-off.
Quite a one-off exercise, but that's fine. We can rebuild. The cutting edge to the drill bit looked fine. It was just the extender pipe.
You need to shorten it up.
Yeah. Thanks, Cody. Yeah, good call. Yeah, we're going to adapt it and make it a shorter stem on that drill, so we got more direct force, more control, more power. And let's just hope that this is what we think it is, not just another bit of outcrop.
That's it? Yeah. Seems to be true.
And it is outstanding.
It's a rock. Oh yeah, there's a rock.
That's a rock. I mean, it's a rock, and this is the first ever outcrop sample from the Great Barrier Reef margin. Rob, looking at Rob Beeman in the background here, just to
It is the formation platform for the Great Barrier Reef. So what this rock is made of is what the Great Barrier Reef has grown upon.
exactly.
Without this larger shelf development, which has taken place probably since the Cretaceous, when Australia broke up with Gondwana, then the Great Barrier Reef wouldn't exist, because it had to have developed this broad continental shelf.
You see the saw mark in it?
Yeah, we've got the saw mark on the face there. That looks like quartz or calcite. This is cool. Okay, well, that's a beautiful payload there.
It's very fine grained there.
Yeah, isn't it? Very fine grained.
Okay, maybe a kind of a mud.
It's got a crack. Let's get it in the box before it falls off.
That can go in A as well.
That's a decent size. That's fantastic. You know, that's...
Yeah, you've really got the internal parts.
Yeah, we've got a fresh round of applause. Thanks, guys. Cool. We shall proceed.
A bit of ancient Australian continent.
Yeah, exactly.
Just landed.
Yep, that's what that is. The underlying geology of the Great Barrier Reef is what we've just sampled.
Well, just trying to think through the literature.
As an outcrop. Exposed on the seabed. 1,345 metres. Water depth. So that was a good start to the morning, everyone. We're happy.
Not too shabby.
Anywhere else you want to go look?
No, we'll like to move towards the canyon floor, so back on our transect, I think.
Just start following the
Yeah, following the transect. Thanks, J-Rod.
Nothing
Yep.
else that y'all saw that y'all want?
No, we'll kick on. Thank you. Unless Jeremy sees
Well, I
something.
see a couple right here.
Do you want to have a closer look at that?
Do you want to come down?
So we went down about 1,000 metres.
Yeah, I know we don't have much time on this dive, right?
Sure.
So,
We might, yeah.
You want to go for a quick sample?
do you think it'd be a quick grab?
I can try to.
Yeah. Yep, do it.
Quick. Attempt at it.
Thanks, Jay. We're here. Now we've set up.
Because it's too small. As soon as you pull that thing out, it doesn't hold.
Well, they're on the rock. Yeah. So there was a lot of things. There was definitely those hybrids. Yeah. So we'll sample them. Okay. So
You want that?
this is the glass sponge.
Yeah, right.
This is, I think this is Faria. This is the genus Faria. It's a hexactinella sponge. It's fully siliceous. It has these kind of almost bell-shaped looking parts of the body.
So we haven't collected that one yet. We've only had the vase.
It's pretty common though. We've seen it a lot.
So we could probably wait till later to grab it.
So since we're here, we may never see one of these on the rest of the dive. We're going to take a close look at this cup sponge, I believe. Cup coral, excuse me, cup coral.
Yeah. Well, yeah. So Tom has been saying that there's this ancient solitary. Looks like a cup coral, but it's made of a different structure. I have the information. So
Now look at this. This is a very small, very small guy. Over to you, Jeremy.
Oh, it's of course A's isn't Delit, and it looks like a scleractinian solitary. So it's one polyp, hard coral, and so this is one of the few scleractinian corals that live in the deep. They're fairly common, and so we want to collect a few of these. On our last trip in this area, when we dredged, we collected a bunch of cup corals, and about half of them ended up being new species and new ranges for the region. So at this depth in this area, there's not much known about these scleractinian cup corals. So we're doing it blind now, but we'll see if we can grab. The colony. No. Not bad. You could throw it in 1A with the rock. That'd be fine. Wow, that's the whole thing. That's perfect. So you could see, so the polyp, it's wide, and then it comes to a narrow point. So the length of that base is indicative of, will identify what species it is, in addition to the polyp feature. Yeah. That was a great grab. Cody?
Well, not bad.
It was pretty good. You went blind halfway through. Did you have a feel? Did you feel it in your claw?
I knew it was there.
You knew it was there, yeah. Amazing.
I became one with the arm.
Awesome.
Don't drop it. You lost it.
Oh. Yeah. Down it goes. You see it? Sweet.
God, these guys are good.
If you could catch it in mid-water.
That would be impressive. Oh, there's...
it's so small. Oh wow, it's really small.
You're kidding me.
If you can balance it on your claw. There. Okay, it won't be worth waiting for the dust to settle, I think.
Okay. We'll call that a missed opportunity. Okay.
That's all right.
Okay. Sometimes that happens.
Cody, it was going to be named after you.
I know. Alright, so You're back on track right here.
Alright. If I close that jaw anymore, it would have crushed.
Yeah, that's right.
The geo just kind of makes it seem like we're just going to build up some currents up above.
There's a question about how did you know where these rock features would be?
Yeah, great question. How did we know where these rock features would be? Well, we hoped they'd be here, I've got to be honest, but we've selected this dive site today chasing the steepest parts of the canyon wall. So where it's formed in its steepest gradients, 20 to 30 degree gradient slope, it kind of tells us that because it's steep, it must be stable and formed in something relatively solid. So our intuition and our experience, I guess, also suggests that, steep in these environments typically is a hard substrate, rock face ideally. So that was our working hypothesis based on the bathymetry, the high resolution bathymetry that the Falkor collected in the last couple of days. So our little hypothesis has proven correct, I think, in that we've seen that rock outcrop in real life. So it's just one little step in building our knowledge and understanding, and I guess our own confidence in the way we're interpreting the data from the mapping.
Someone named the coral that we dropped.
Someone's given a name to that little specimen we just lost, called Lost Specimus codii.
And Cody has left the room.
Oh, g'day Emily, good to see you online. How are you?
Yeah, I see that on the left. I can see those.
So we just had a change of ROV pilot crew while they settle in, and we'll just really commence our transect proper. That was the start of it, and clearly had a really cool site to start on and took some samples. Adam and Chris have joined us as ROV pilots. So as the cloud clears, hopefully we'll get a bit more of a vista. What's the grid resolution on the bathroom?
There's another one of those eels that we saw yesterday.
Hey Eric, that's an updated waypoint for you. Do you want me to stay on this little thing here?
I think there was a name put to this fish.
Yeah.
Let me stay up on this little ridge and we go down further.
One of the things it always opens your eyes when you start looking at the seabed in real life, as opposed from the maps we collect, which are remotely sensed data sets, is the detail. And overnight, in the last 2 nights, in fact, we've mapped the seabed in great detail using the Falkor's multi-beam sonar systems, and produce maps which give us a horizontal or a seabed resolution of 10 metres. So that's the level of detail you see. And clearly, once we get down here, we're seeing stuff at the centimetre scale. So a 10 metre footprint on our map can be characterised by a lot more detail. So you've got to sort of adjust your mind to that scale mix.
You want me to follow all the way down?
Yeah, thanks. Yeah, keep going down. Trying to find what we expect to be the floor of the true floor of the canyon axis, effectively. Just to have a closer look at that. Thinking that it should be a soft sediment area, but we've been proven wrong before. Quite challenging for the pilots, I think.
Floating through there. Is it a holothurian? Just
Yeah, that pink one. Okay.
Floating past on screen, that's probably a holothurian sea cucumber.
seems odd in the middle of canyon, though, don't you think? Or is it a leaf?
No.
No, it'll probably swim in a.
It's just sitting there, maybe sleeping. It seems such an unlikely environment to be in a really, really steep canyon area. There's certainly a lot of sediment around. Pretty much any flat surface has got a drape of sediment, which is calcareous, likely, raining down from the shallow water corals nearby. But to have it kind of just sitting here mid-water, looking like it's fast asleep, because we have seen them swimming, but they're swimming actively, whereas this is just sitting there.
Should be a personality
Maybe
trait.
it's possible it's
It's really
deceased. Hate to say. No, it's good. No, it's good.
There we go.
There we
A bit
go.
of movement.
Waking up.
There we go.
There
Where
we
it could be
go.
from the propulsion.
Yeah, but see how soft it is, our ripples with the currents. We saw Beauty yesterday, and it was 378 died. It was swimming. We zoomed on, you could see all the different little papillae, on the things.
Dougal's given us that ID, has he?
Maybe it's napping. Yeah, I agree. There we go. Bit of movement.
Yeah. It is Sunday morning after all.
We're going to zoom in on its.
Oh, that's beautiful. Yeah, do have that.
Higher up. Yeah. Oh, it's alive.
That is pretty amazing. With that background of the canyons.
Yeah, that's a starter. That's
What an alien.
Yeah,
it is very alien, isn't it?
and it has the little purple papillae on the scattered all over it. Do you remember the one we saw yesterday had these little white dots on it, and we weren't sure whether it was part of its skin or whether it was just debris that had stuck to the side.
I think it's all white spots on this one as well.
Yeah.
Come on down.
Leave that one behind. Nope. Such an unusual environment to see it just floating past. I mean, look at the wall is
Vertical. Yeah.
and yet the bathymetry maps just don't quite do it justice.
That's
do
right.
they?
Yeah, that's
to give you a sense of how steep this is.
Oh, can we look now?
Jeremy's just spotted her.
So, you think this could be a coniferous sponge?
Fields paper. Fields paper. The view on the wall.
Do you want to zoom in?
Yeah, I'll just. That's okay. You can. Oh, sorry.
You want it, Jeremy?
Field.
There's a bunch of stuff on the right.
Oh yeah. Whichever one's easier to get to.
If you want to look at the multitude of stuff on the right, I can set it.
Yeah, sure. Sure. Yeah. Yeah, probably.
We always get that down.
So we still haven't collected a coniferous sponge, and maybe this is not that. No, this is a soft coral.
Scan that vertically. It would be a very
Yeah. It's very fine bedding. Very.
It looks sponge-like. Jeremy,
Do you think it's?
thoughts?
Yeah, I think it's a sponge. Yeah, it's hard to get a zoom in while we're hovering.
I can set it up.
But we could.
Look at strata.
Yeah, the strata there. It's old.
Set it on the wall.
Yeah, I mean, look at that. Okay, so
Yeah,
it's folded.
Yeah,
folded.
I'm just trying to grab it
Fresh
for the
up.
back.
Yeah.
$5. Yep. Yep.
Oh, okay.
Those are
Yes,
anemones, right?
No, they're. Eric told me they're really. I'll find out. They're really quite unusual.
Down. I'm gonna zoom out for just a second.
Yeah, go for it.
Just to get a reference.
Mm-hmm.
All right.
Are you gonna rock them and sock them?
Yep. 2 for 1, yeah.
Good view of this rock face as well as we prepare to take a sample of these creatures growing on the rocks. In that you can make out those very fine lineations, which are bedding lines within the rock. But it's all very gently folded and contorted and at quite different angles as well.
So we're gonna store covered.
So sedimentary in origin, but probably metamorphosed as well.
Never mind, I'm back off to do it again. Is it worth it? Yeah, no worries. Yeah. The angle only forces us to be able to go on. No, because there's some stuff below that we might want to get, so give us more access like you just, you know.
So, and when we attach to this wall, it'll be a good opportunity to look at the really high, look really close at the rock face.
Yeah, yeah, get some images.
Yeah, a lot of life on this section. You imagine the currents are in the right, it's in the right orientation to obtain the nutrients that are passing by.
Yeah.
Hold on.
Question.
I wonder.
It's
Locked it, I unlocked it. Why did I do that?
I talked about using the multi-beam to guide the steeper slope selection. It's our little working hypothesis.
Can we
which
lower
we've
the
now
light
proven.
a little bit? While you're getting situated, I'll just take a zoom in.
Yeah.
Ah, thanks. That's good. Is it okay to zoom in?
Yeah, go ahead.
Okay.
It's gonna hold it. And then
Jody,
Especially if there's 2 kids at home watching.
That's okay. Okay.
No, you're fine. I was trying something and it didn't work.
Okay.
So I got a free flight.
All right.
I can't lock onto it.
Do we have manual focus?
No, it won't reach.
Can I get manual focus on?
It's on.
It's on. Okay.
Here, try that.
There it is. Nice. Oh, look, it's got a canal running through it and out the end. That's interesting. Okay. Yeah, we got our image. Let's grab it.
nice close-up view of the rock as well. That's very
connect, right?
fine strata.
Are we going to connect to the rock?
I'm on with one left right now.
Oh, okay. Yeah, go for it. And
Hold on. Let me see if I can. Is it gonna hold? Yeah, he can collect it right now. I can fly.
okay.
Free fly it if I need to, but it's holding the right right now.
Okay.
Okay, you happy for me to collect it? You want it right from the base in?
Yeah, please. And you could put it in by box 2, I guess.
All right.
Might be better in the. How long is it here?
It's hard to.
It's pretty long.
It's pretty long.
Yeah, okay. 3, 4.
Yeah, probably
That long.
4, yeah.
Sweet. You'll probably want to grab it nearest to the base. It may, and it's okay if it does shatter. If it does, you know. Oh, there was a. Oh, hang on there.
Yeah, like 2
Is it a
inches.
fish? Or
Oh, yeah.
prawn?
There you go.
Okay, that's good.
Good grabbed it.
Beautiful. Look at that. It's like a
Alright.
plunger. You know, just.
Let's just not drop it for frozen.
Yeah, it's okay.
Sealed the right jam.
Yeah, is that what you did this morning?
It's like full.
And while we're here, do you want to get a close look at the rock?
Oh, that was good.
Okay.
Yeah, that was good.
Is there anything else you want to collect? Or
Two for
some
one.
other-
No,
No.
we can keep moving on up.
We'll keep moving. Thanks.
That's good. It's
Yeah.
just that we've seen a lot of this, and I just want to get one of them at least
Yeah,
to
cool.
reference to.
All right.
We'll box that and move on.
Sweet. Tom Bridge said, "Good to subscribe to me." I think you wrote that message before we dropped it. Sorry, Tom. Next one.
Hold on. Better views. That.
All right.
I'm gonna buy you a Christmas present for Christmas too. On the internet, by the way.
Just one Christmas present.
Okay, one half of one and one other half of one. We need the 200. So.
They were pretty good, actually.
They were wonderful, amazing.
Meta sediments. Probably.
So I'll just explain, I'll take this opportunity to explain why we're collecting biology on this expedition. So in addition to understanding, what the Great Barrier Reef and the Coral Sea are made of, what's the substrate, how it formed, we also want to know what's living within these habitats. And the only way to understand what species are living within them is to collect them. A lot of these specimens are really hard to identify from images. And we're now using advanced molecular techniques to identify the species and understand the evolutionary histories of these various anthozoan groups that we're working on. So we're collecting what we call morphotypes of each what we think are species. Morphotype is different suites of morphological features for a given species. And what this allows us to do is identify whether we're looking at one species or multiple species that have one species that has variation or multiple species that are distinctly different, and what morphological features can be used to separate the different species. So that's why we're collecting these colonies, and sometimes we're going to collect full colonies, but we only collect what we need. So we're very careful about what we end up collecting.
Okay.
So just when they follow on the bottom, and we go.
So we're looking at the canyon wall, I guess, are we?
Yeah,
And once-
facing-
The
facing
canyon's
west.
coming down in front of us like this,
Right.
and then he's kind of dropped off like into the base of it. So if he comes up here and then turns kind of 90 degrees to starboard, he'll go and start coming up the side of that wall, which is deeper.
Okay, right. So if there's anywhere we can find if there's a flat bit of soft area to take a core,
Like we're
just behind down here, is that?
Yep.
Yeah. That's what we
I don't know
do.
how flat it'll be.
Yeah,
but
it's
I'll find
hard. Yeah. Let's have a
out. I can try to sit down and see what happens.
see what happens. Yeah, it's so steep. It's crazy.
Bridge, ROV.
Yeah.
That's an updated waypoint.
So take what we can get.
Tom Jones in my head.
YouTube might know that's because I'm singing. It's not for copyright infringement.
So we're just landing the SuBastian onto what appears to be the very narrow axis of the canyon. Our objective right now is to try and find a spot that would be appropriate to collect a short push call into these sediments.
Not necessarily flat, but
No, that's just not. That'll do.
Flattish.
Flattish. We'll take flattish as good.
You guys haven't taken any cars yet, have you?
No,
Not today, no. No.
So Rachel's asking to put a bathymetric map in it instead of
I'm gonna forge out.
We'll see what this.
No, I'm gonna do it gently. Fine. It's a long bit. My fish is off actually, which helps.
Do you want to land the port chart?
You know that. I've been doing it so. No, you can't really land. Right. Either where we're at.
This might just be avalanche.
There was a question about how many samples we can collect per dive. And so in the Great Barrier Reef, we're collecting no more than 5 specimens per morphotype. 5 specimens per species. And we, I think, probably only hit 1 species at most per dive among our targets. So we're well under our limit.
Why don't you push up with the rails?
Yeah, but we need to be out. We need access to the port.
I don't know, just shoot up with the rails and then you can port chart.
It's a deep sea design. Just looking for the anchor to confirm it, but I'm pretty sure from my memory that's what it said. And so the head drips down and it has this kind of strain of water. But they really pointed down and whistle.
So for those looking at this operation for the first time, perhaps, what the ROV pilots are currently doing, they've just taken out a short cylinder, perspex cylinder, which we call a push core.
It's push core number 2.
Push core number 2 is the numbering system that we use. And it's a really quite a straightforward operation where we just simply use the hydraulic arm strength of the SuBastian to just push this core as far as we can. Ideally the full way is about 20 centimetres into the seabed. Which we've done very well just there. Give it a little wiggle to break it away at the bottom of the core and extract it nice and gently, so that excellent. We have full core recovery, which is always a great thing. Sometimes they do fall out, but not today. And then we just slide it back into that little holder.
It's my zone theory. It's a corallimorph. It's closely related to
You can tell looking at the top of the core is perfectly undisturbed from that sample, so it gives us a pristine sample of the seabed. We'll take 2. Thanks, that was pretty straightforward, yeah.
The tube anemones, these are the true anemones. So methods.
tube anemones, actinaria,
and we'll take a duplicate because we have a number of people interested in these materials, these sediments, for potential analysis back in the labs.
Can we just stick it up somewhere? I think it's really useful.
Yeah.
This will be pushed forward.
Seabeds, soft coral beds, just 2 types of soft coral beds.
Yeah, they're probably separated.
There's that sort of extinct one, is it?
Yeah, I'm not sure what that is.
Okay. Alright, that's good. It's a corallimorph.
Okay, that's really interesting.
As we zoom right in, you can see all the fine grained detritus of bits of shell fragments on the seabed. These all rain down from the water column, or sometimes they'll be transported by stronger currents coming off the Great Barrier Reef, perhaps during flood events. Certainly during the tide every day. So over time you have an accumulation or a vertical build-up of the sediment record, and that we use as sedimentary geologists to understand the history of sedimentation, where it's come from, its age. It's a relatively short core by way of core standards, but it's still a great insight into understanding and characterising the recent environments of these canyon systems. very fine grained, as you can tell from the cloud of mud left behind. So fine grained sediments take a long time to accumulate, so there could be a decent record of time in that. Perhaps 1 to 2,000 years if it's an undisturbed site. Okay, excellent. That was a nice quick hit right there.
See the three dots down there.
Yeah, you can. Yeah.
So what you tell me, is it bacteria or is it walking oxygen?
Thank you, Chris.
It's kind of making it acidic. Is that what's wrong?
Oh, what is that?
My understanding is that it's absence of oxygen.
Wow, that's kind of...
Is it a big crayfish?
Looks like a cray.
It's a crayfish, look about it.
Yeah.
Because we have them in the shallow waters here, they're called painted crays, and they're actually a commercially harvested animal. But this is the first really large lobster-like we've seen in the depths here. We've seen plenty of shrimp, but this is a beauty. And good size too. There's a dinner plate size.
So those two green dots are 10 centimetres apart.
So that's a good 30 odd centimetres across the body. Really unusual. For this size at this depth.
It's going to get where I just came up. Since we're buried in, it's going to get this to the second.
Yeah.
And again, just kind of strange. I was just sitting on the floor of the canyon.
Must be a lot of food, it's probably
Well, certainly look at all organic matter, the sediment we're washing up here. It's quite soft, but isn't that beautiful?
Lovely.
Doesn't body size tend to increase with depth? Certain things,
Well, yeah, for sure. You can get this gigantism happens in different parts of the world. So in Antarctica, you can have these giant siliceous sponges, really strange gigantism occur. But out here in the coral sea, we have seen some fairly large spider crabs. A good 30 odd centimetres across the body. But I mean, this is a completely different animal. It's a lobster. It's a decapod, obviously. It's got 10 legs, but you can see it's so it's the antenna. They're drawn back, and then you've got the chellae. Do you see how the chellae are actually spread? So this, you notice, right? That's its claws, right? So that's one long solid piece, and so then this is 90 degrees back, like
wide open,
ready to catch whatever is coming past here.
Wow. Or is it defensive for the ROV?
It could be about to attack.
Yeah, that's amazing.
Yeah. So you see this one here is actually pointing towards us, the top claw. So you're not getting quite that perspective, but if you're, I don't know what they're eating, they're like, might be other small shrimp and the like. Once those claws close, you can see the teeth. The teeth along those claws. You're not going anywhere. Right? You are dead meat.
But we'll leave them alone.
Yes.
It kind of reminds me like a Venus flytrap, like there's the claws you get on that. But this is really spectacular. Yeah, and really large. We saw some fairly large shrimp and things yesterday. Maybe 10 centimetres more. And we got looks like a polychaete.
Little polychaete worm.
Yeah, just having a bit of a swim.
Probably get kicked up from this.
Yeah, we probably
So these kind of polychaetes, the Latin is there's sedentaria, which is the sedentary or in the sediment, or errantaria, which is erratic swimming, right? That's the latter.
Okay, let's move on.
Alrighty.
Thank you.
That's beautiful.
Beauty. Yeah.
Thank you, Chris.
We'll leave them. But crayfish are common in the shallow coral reefs of the Great Barrier Reef. But during daytime, they are typically hiding, right? Because they are food for lots of animals. Octopuses is a classic predator of crayfish, and everyone likes eating those crayfish. So during the day, if you're scuba diving in the Great Barrier Reef, you'll find them, but they're always tucked in holes and things. At night time, you see them come out. Right. That's when they're more common. I mentioned that there's a commercial fishery for painted crayfish, and they have is it a hermit crab?
Is that a little one with it?
Hermit crab in a hurry.
So there's a commercial fishery for painted crayfish, and they're worth a lot in the restaurant trade because they have this beautiful coloured shell, painted crayfish. They command a higher price than your standard Western rock lobster. And so in this part of the Great Barrier Reef, they have a crayfish fishery, and also up in the Torres Strait, not far from where we are.
Yeah, I wonder how deep they've been recorded. I mean, in this part of the world, this might be a bathymetric extent,
Well, that's definitely not a painted crayfish, but, just to see one of that size, a crayfish of that size at this depth is pretty amazing.
Yeah.
There's the...
We've been here before, haven't we?
Oh, you recognise that?
I recognise a bit of that.
And these are corallimorphs. Okay, so these are hexacoral. Jeremy, do you want to talk about them?
Yeah, so we were... so this
Center of the screen, they're hanging down.
Yeah, so this corallimorph is... So you would assume it's closely related to the sea anemone and the zoanthid, because they have a similar structure. But they're actually sistered to the heart corals and the black corals, which is pretty odd if you look at the phylogenetic tree. But as Rob was saying, so they have this polyp that faces downwards.
Quite a good size too.
And
it'd be 10, 15 centimetres long.
Yeah.
We saw them on the previous expedition out in the Coral Sea on the sides of these large reefs. In places hanging down, they've got these little dots along the main body, but you can see the tentacles hanging down. They've got this almost umbrella-like, what would you call upper mouth, but it's definitely hanging down. None of them were pointing upwards, so I think that's quite interesting.
Right. Well, I guess that's an easy way to differentiate them from the anemones.
Yeah, but maybe it's also something to do with how they feed. So, if you're facing upright, you're going to get a mouthful of sediment. Clearly, that's a lot of sediment coming down from the shallow coral reefs above, and so maybe a behaviour is to point downwards. And rather than get a mouthful of sand, you can actually just catch whatever's just.
Yeah, another cup coral. Wait a second. Can you look closely at it? Does it look like it has tentacles inside?
I can land out. Right now there's a big overhang above me, so I can come down a little bit.
Let me pull up this
Get a better look.
document I have here.
Gee, there's a lot of life in these overhangs, isn't there?
Yeah,
Really
sure
amazing.
is. A lot of life. So now, where are we? Tracking up.
We're
Climbing the other wall.
just on the other side.
Yeah, okay.
There'll be a little bit of a rise, and then
Yeah.
a flat, and then there'll be quite a steep.
Yeah, we need to make some tracks, I think.
Alright, so
Yeah, well, it's okay.
Yeah,
If we need to go, it's okay.
Yeah.
There'll be cup corals. So
Yeah,
it's,
okay.
It's okay.
let's push on.
Sorry.
my rails back in.
Yeah. Yeah, it's a good question.
Alright, Adam, I'll turn to the right a little bit so you can see what
Perfect.
Yeah, okay. Yeah, so I'll go for time 11 now, isn't it?
It's 11 o'clock.
Just to start. Another 2 hours, isn't it?
there is definitely ledge above it. Back up.
By 2, relocate.
Oh, not me now.
This would have to get a bit of a wriggle in.
Yeah.
I did jelly.
Jellies.
Yeah. Or we, yeah.
It's a working backwards.
Oh yeah, sure. Sure.
There's actually two of them.
Yeah. Let's check it out. We'll try our best to keep it in the claw. I got faith in this crew. The last guys, I mean, you know.
We usually want them to the open water, blue water. Alright, there's actually...
Let's look. Can I take a...
Hold on. For ease of reading it, I'm going to get that one that's right there in the...
Oh, that's an easy one. I'll just do a slow zoom in. Alright, so we're doing a second attempt on a cup coral. I'll let us settle down and then we can take a look. Sorry, shrimp.
Yeah, I mean,
Okay, are we settled down?
Wait a second.
Okay. It's actually interesting. It looks like a different cup coral up there.
Different type.
Do you think we could reach both from the same position?
Oh, we might be able to.
Yeah, okay. If possible, we could. Steve would suck them, scoop them, like suck them up.
Okay.
And you could suck them into the same tube. It actually worked really well last time we collected the hard coral, the cup corals.
So we're going to use the section sample.
Yep, so what we're seeing here is what seem to be at least two different types of cup corals. So scleractinian, solitary, so one polyp corals. And as I explained earlier, a lot of the species in this region are being described or not yet discovered. So this is a good opportunity to grab a few and send them to Stephen Cairns in the Smithsonian Institute, and he can let us know what they are.
Is one available?
So
One's
one jam on the bottom.
Yeah, suction.
One's good.
One's good.
Yeah, sure. Oh, sorry. Yeah.
Another hour to transit. That's very conservative, generous. Then nothing out to the sun. 2 hours on the bottom. Yeah.
So today is going to be an interesting day because our goal is to do two separate dives, and that presents the challenge of deciding when to end the first dive and come up. Actually, can I take a close view before you suck it? I'll just zoom in.
On the
Then I'll focus. Oh yeah! Look at that guy. Okay. Suck away.
Alright, I'm going to come up on...
So, as I was saying, we're trying to just figure out the logistics of when we end this dive, start the next dive. We want to maximize our time underwater, but there's two different locations that we want to explore today.
No, we're not coming back, and I don't want to
The alternative is the can of transit tomorrow. So we push that in envelope a little bit.
Oh, there's tight, huh?
Yeah.
I like that. There's quite a big factor that's actually
Or try to fuck it up? Yeah. That's the one. Half of it at least. Just the whole thing.
No, it's okay. Forget it. If we could, I'll zoom out. There's another one up above.
Maybe easier to fuck this guy's journey.
Okay. But actually, the other one might be a little bit. This one might be a little easier to suck.
This gives us a good break. So if we aim for this 1 o'clock,
That's interesting looking. Yeah.
you know, we spend 20 minutes, 30 minutes getting it.
You reach it.
That's taking us close to 12 minutes. It might be look at this 500 meters, we ran out of time and pulled it out. But at least we've got it.
I'll see that.
We'll try our best to grab from the, get the whole base as well.
Yeah.
Everyone can't menu too long anyway today.
All right, we got it on the floor. I guess you can just suck it up with the sand, yeah. We could assume it got in there.
I can shut off the suction in a second. Okay.
Yeah, we got one.
Into one.
Yeah, one.
You want to try to just grab the one that was below us?
No, because it was already broken. There'll be plenty of cup corals to spend time collecting.
And then kind of get that general plan to the bridge as well. Let's start with JAMSTEC. Reef is team.
It's okay. I mean, if you didn't get it, it's gone anyway.
We're just going to look for it real fast.
Okay, cool. Yeah.
That's one.
I can torch in. Easier for you.
That's good pictures.
Are you grabbing that, are we? Or...
No.
No, okay, well, I'll just stay here. Just going.
Well, you can see all the mud that's built up down below. So just above us, well, probably about 4 kilometres away from where we are now, is Ribbon Reef 5. So think of it like a big wall of coral, and you can scuba dive on it. It's lovely diving there, and that is the basically where the head of this particular canyon starts. So this is what we technically call a reef-blocked canyon. So the reef is right at the very head of the canyon, and so you'd expect that most of the sediment here is likely calcium carbonate, coral pieces and the like, just rain down from the very steep, shallow coral reef. It's just 4 kilometres west of where we are now.
Onwards and upwards to join the start of our 500 metre transect.
So we're now working up the north sidewall of this very steep sided valley. This is V-shaped here. If you recall, yesterday we were down on ROV dive 378 and that was U-shaped. So as you go further down the canyon axis, the valley floor becomes wider and flatter. But as we're in the kind of middle zone of this canyon, it becomes more V-shaped. So this is reflecting of the erosion that's cutting through this hard rock. So Marty McNeil kind of reflected on, the time it has taken to incise, to cut down into this hard rock, and you can imagine it's probably millions of years of development. Not only millions of years to build up the hard rock that now forms essentially the edge of the Australian continent, but now is being cut into through erosion. So we're heading up the north sidewall, and we're sitting on top. There's lots of this white sediment. This is calcareous sediment coming from the shallow reef higher up on the Great Barrier Reef itself. So it's interesting, anywhere where it's overly steep, that sediment doesn't build up and you end up with this great layer of white sediment, which has got marine life on it. Of course, it's mainly what we call Lebensspuren. This is German for life traces, and it leaves these characteristic mounds and burrows and trails left behind by lots of animals. But you can see an eel over there just sitting down on the slope. It's like a big ski slope, isn't it? So it looks like trails, and there's another eel that's kind of just hanging there on the halosaur, thank you. Yeah, so we value our fish army and experts ashore who can help us ID some of these animals. But for us as marine geologists, we're really interested in the rocks too, and what we're seeing is really the very easternmost reaches, the outermost limits of the Australian continent. Right, this is the hard rock on which the Great Barrier Reef has grown. And of course, there's lots of questions around the age of the Great Barrier Reef, and we still don't know. We have a bit of an idea, and that's from a very long coral core that was taken through Ribbon Reef 5, and this is the reef that's closest to us now. So it's not an accident that we're here. We purposefully chose this particular reef to come and visit because of some drilling work that was done in 1995 by some marine geologists. They were interested in trying to understand the origins of the Great Barrier Reef, and they actually set up a jack-up drill on top of Ribbon Reef 5 and cored down. They got a core sample. It's about 200 metres long, and my close colleague Jodie Webster at University of Sydney has been very much involved with all of this study to try and understand the ancient Great Barrier Reef. But this is the longest coral core that's ever been taken on the Barrier Reef, and it tells us a lot about the different cycles. There we have a nice big squat lobster. Yep, another decent sized one. Beautiful red colour. It's hanging underneath. Chris, have you got the lasers on? Okay. So we're probably looking about a good 10 centimetres across there. But because the rock itself becomes an excellent habitat for all kinds of marine life, and we're seeing some mobile creatures like crustaceans, shrimp, the squat lobsters. But if you have a look to the left, the sort of top left of that lobster, there's this sort of strange net-like, almost like a plastic bag sitting there. Well, it's not a plastic bag. We think that these are probably the discarded remnants of basket eel homes. So there's a type of eel here. We've seen them before, great cutthroat eels, basket eels. They're kind of long, thin eel, and they create these strange mucus-like nests, in which they kind of almost stitch them to the sides of rocks, and then they hang inside them. And there's another one in the crevasse. Almost in the center of the screen. No, sorry, I'm imagining things. Yeah, so you see these discarded kind of mucus bags all over the place. Jeremy, what are we looking at here? Is this a bivalve?
Very large.
Yeah, yes, please. If we can just sort of, I'll see if I can zoom in. Of course, we've got this beautiful long-legged shrimp above, and I'll just come left a little. It looks bivalvish, but it's got this quite strange looking mouth. It could be just the mantle that we're seeing on the inside. Anyone from ashore, any ideas? Now, I'll just throw something else out there. Could it be a brachiopod? Okay, so we have seen relict brachiopods. These are living relict animals in the deep coral sea. Because brachiopods had their heyday 400 million years ago. I need to get my zeros right. When, I guess bivalves were in existence then, but back then, this is sort of Permian period, the pre-Permian extinction. The brachiopods ruled the shallow seas, and you can walk on fossil remains of just millions and millions of brachiopods, thick-shelled animals. Look very much like bivalves now, but after the Permian extinction, they mostly disappeared, except for a few remnant species that are still in existence today. I think of lingula. This is a small thumbnail-shaped brachiopod that you can still find living in the deeper oceans, and quite amazing, but unchanged as a species over 400 odd million years. But so anyway, I just say that out there. There are brachiopods in these worlds. Bit hard. We need to get a bit of a move on. So just talking about today's plan, we're trying to fit in 2 ROV dives today. This one in the middle part of the canyon, so we're now at 1,350 metres. What we need to do is move along to the start of our 500 metre transect, which is part of our standardised sampling regime. At the end of that transect, we'll recover it. It'll be probably around about 1 p.m. this afternoon, our time. The ship will then mobilise a little bit further westward, closer to Ribbon Reef 5, and then we'll do a more shallow water dive, probably around 300-400 metres, and work our way as high up into the shallower mesophotic zone as we can. So we do have to get a bit of a move on. Of course, there's plenty to look at, but there's still a lot to discover. But in that time, we need to recover the ROV, move the ship, drop it back in the water again. So there's still a lot to happen today.
Good, you want to?
If we just see how long to get to it, so just
Go for it, yeah. Good call. So, yeah, do that.
Yeah, that's another 130 meters waves.
Okay. So it's far along there.
We can start early.
Yes, I do whatever you want.
Want to start it here?
yeah, I mean, we can start it here and then end at 100 meters earlier.
Yeah, it'll buy some time.
So like this, and you want 500 meters, you said, right?
Yeah.
Yeah, that's good.
All right.
I'm going to give you grid distance.
Yeah, so
You still have to do it.
350 distance. So it's 450.
Approximate. So it's
Okay, so we're just having a discussion here about the start of our 500 metre transect, and when we get going, we won't stop. We just have to go to a steady rate at a set height, and we're doing this for every one of our ROV transects on this expedition.
That's just the 1 year distance. Anytime I go up, you're down as well.
do they care about the seafloor? One thing is you've changed the angle there a bit, which is maybe going to change your distance. But finish it. Okay. Depends how exactly you want it. We're not going to spin that.
Okay, and off we go. And we have Stephanie in the event logger, and Alex is sitting on the squiddle desk, and so part of the exercise is to log everything that we see during these 500 metre transects. This allows us to do a comparison between all of the various transects that we're going on. Now, it's no accident which canyon we're going up. We're trying to test the idea of how these canyons vary across this really complex deep Great Barrier Reef area. So we're just seaward of what's called the Ribbon Reefs. We're about 80 kilometres or so north of Cairns in northern Queensland. We're about 60 kilometres east of the continental shelf, and we're coming across a really steep wall here, which means we have to climb up it in order to move along it. But yeah, we're actually really amazed at just how steep the environment is. We've got lots of interesting animals on this wall. So we've got corallimorph, that's this sort of anemone-looking animal, but it's definitely a corallimorph. We've got farrier, two different kinds of farrier here. This is a genus of hexactinellid sponges. Looks like we've got some comatulid feather stars hanging off the side. Yeah, quite a few hexactinellid sponges. They've got this classic translucent white look about them. And of course, if we were to zoom in closer to the rock, you would actually see a lot more marine life. Dougal, I'm not sure if you're watching, you can see just sort of some plankton going past. We've got sea stars on the left here. But if you look beyond the marine life, really spectacular rock formation, you can see strata in them. So where the rock is actually broken away, you can see the layering. Now the whole thing is dipping, okay, so it's not horizontal by any means. So we're looking at sheared faces and exposed strata. And in places, you can't actually see that strata. But overall, what we believe here is this is a sedimentary rock. It's very old. It's certainly hard, and it's probably been metamorphosed. So it's had a long geological history of warping and pressure that have given it these, sort of folded look about the strata. So it's really quite an ancient rock base, and of course this is what the Great Barrier Reef is growing upon. Sorry. Yeah, I understand. Yeah. So you're going up, maybe. Yeah. Like Chris, one of the pilots, is just talking about how steep this is. So we're actually on a 500 metre transect, and so far that other transects have been quite easy because it's generally off a sort of gently sloping sidewall. But like when we put our plan in last night, I don't think we really expected it was going to be so steep. But here we are going up literally vertical rock faces. and if this is part of our 500 metre transect, we just have to work with it. But yeah, clearly just beautiful environment for lots of attached marine life. We've got a feather star hanging off the edge. I'm keen to see a sea lily or a stalked version of those feather stars. We have seen them on other dives, and they're a really relict animal. So this could be an environment that we find them in. So keep an eye out for them. Yeah, I agree with you, Dougal. This is some cliff, and I'll just repeat, we did not really expect it to be this kind of exposed. So, I mean, this has been mapped very well, both previously by myself and Jodie Webster, our other colleague, who's unfortunately stuck in Sydney. It'd be great to have Jodie here with us, but last couple of nights, the Falkor has been doing a fantastic mapping job through the night, because this is very well covered now. We had a good sense, three-dimensional sense of the seafloor, but again, just repeating what Scott was saying earlier, you kind of got to get your head around when you put a camera down. Oh, there's a halosaur coming in. Oh, look at that. Oops, gave me a bit of a fright. Remember, without these lights, it'd be pitch black down here, so it would be quite imagine it from an animal's perspective, in the pitch blackness, and then there's big, SUV-sized beast comes out of the darkness with great lights. Would be a surprise. I can clearly see folded strata here at the bottom of the screen. You can see that layering, but it's got that kind of warped look about it. So this is classic. So if you metamorphose a sedimentary rock, you start creating all these folds and things. So I guess the original rock material would have been sedimentary. Now this could be multiple layers of sand, mud. Because we now have a rock sample, we can actually look at that and see what the internal material is made of. But then you also need lots of pressure and time, geological time, to start folding it and creating all these different shapes. But ultimately, it's just this magnificent habitat for marine life, and we've got cup corals here, lots of siliceous sponges, hexactinellid sponges made of silica. Still very cold, it's 3.6 degrees Celsius. We've got Emily Twiggs online. It's great to have you joining us again, Emily. She's been watching us regularly through this expedition. Yeah, and so I guess the beauty of this voyage is that we can combine both that geological insight and bring in the biology as well. I always say geology drives biology. I'm not sure if Jeremy, it's a bit of a competition here, but I do love looking at the rocks. But yeah, it's fascinating to see what's down here, and of course this was the real unknown. For us was the real frontier. Over time, we've actually mapped really well this margin, in a three-dimensional sense using multi-beam sonar. And we have been doing this for 20 years, or in my academic career, I've been doing it for well over a decade. But we still had not put a deep camera down here to actually see what that seafloor looked like, that three-dimensional seafloor looked like. So this is really, really unique. And again, I'm just so surprised at just how steep it is. Now, we had an understanding it was a fairly steep gradient just from the three-dimensional, the 3D pictures that we generated from the sonar, but actually see it physically in front of a camera is something else. It just seems way more steep than we thought. Lovely big brittle star just in the center of the screen there now.
I think she would understand.
And we're still in our 500-meter transect, but instead of going very far horizontally, we just seem to be going up and up. So I'm wondering is this ever going to top out? Got a lovely shrimp just sitting under that ledge with a, I don't know, maybe halosaur. I admit my fish species names are not that great, so I really have to reach out to people ashore who can ID these people, ID these fish. Now, interesting, looking at the rock, you see this sort of lighter coloured brown on the left. I think this is probably a face that's actually given way. So it's this rock stained with ferromanganese oxide. Sitting over there now, it could be cup corals. A little hard to tell because we're just having to sit off the rock a little bit as we're doing this transect. We can't follow really, really closely to the rock here in order to do this transect. Okay, looks like we topped out over that reef, cliff rather. But it's still very steep. But if you have a look over on the right-hand side of the view, you can see that's the crest of basically there's a series of gullies that are draining into the main trunk channel. Okay, if you think of almost like a river system, so there's the main river, that's the channel of the canyon itself, the main trunk channel, and then there's a whole series of gullies. Now these gullies have all different scales, but they're all essentially draining into that main trunk channel, and we've deliberately chosen our 500-meter transect to cross over through several of these. Now we're crossing over them diagonally, so we've come up the left-hand side, or it'd be the western side of this gully. We're cresting the ridge between two gullies, and we're now dropping onto the western sidewall of the next gully. So this is really interesting to see. So we have mapped this, we have a good three-dimensional sense of what these look like, but what's really interesting is how sharp the base of these gullies are. Okay, now the gullies can be hundreds of meters long, but they're the main source of all of the sediment that's coming down into the main trunk. Think of it like the big river. This would be a creek. That's one of several or numerous creeks that are draining smaller catchment areas into the main trunk channel of the canyon, which is now behind us. So we've just crossed through one of those gullies, and we're coming up to the crest of the next one. So again, it seems to be very sharp delineation between a gully on one side to the gully on the other, and now we're coming over the top, the crest, and we're now into a different catchment, and you can see off into the distance now, probably a few tens of meters away, is the next gully, right? And these gullies fill the sidewalls of the larger canyon, right? So if you can imagine just one after another, going down, channeling, and in fact you can actually see them branching off. So it's not just one branch, they're multi-fed. You can see there was one going off to the left, and there's another one that's just disappearing off the left of the screen now. And now we rise up. It's really good, isn't it? Yeah. Oh, here we go. Who's living in this hole? I do love these big burrows. I'm my fingers crossed for a giant isopod, but something's definitely had a bit of a dig in there. I am putting my money on an isopod, but we can't kind of hang around, unfortunately, because we're on this transect. Wow, look at that! Well,
Wow.
yeah, something's had a good dig in that, but you can see it's quite soft. You know, seems steep. Okay, so we're coming up over the crest of where the two gullies are joined together, and now.
We're just doing a 500-meter transect, so I'll just keep kind of
And we're looking down into the next gully, okay? And clearly this gully has lots of different smaller catchment areas draining into the creek. Imagine the creek then drains into the river being the very bottom of the canyon. But boy, have a look at these eels. They all seem to be pointing up slope. Maybe that's if the food's coming down from there, that's where you want to keep your mouth pointed to. But yeah, this is really something else. Right, so we were expecting to see this numerous gullies all linked together. This network of gullies, but it's also it's just something else to see that in a real picture of it. And yeah, it really is steep. So we're now climbing up the eastern wall. Oh, this sort of looks like it's given away there, and we're seeing a whole lot of these burrows. Again, we've seen this sort of clustering of burrows before. They were giant isopods. They have this classic flat-floored dome shape. They're about 10-15 centimetres wide. The isopod itself is pretty wide, about 5-6 centimetres across. And where we have these sort of vertical faces, we had found lots of burrows in them. So be great to see a living one. But now we're coming up over, so we're tracking diagonally across the northern sidewall of the main canyon, which is made up of a whole series of gullies. And this is we're coming up to the crest of the next gully. And as we look off into the distance, we're now falling down into the next gully. There is really, what's interesting is really distinct little, what would you call that? Like the floor of these gullies. They're really narrowly defined. Clearly the sediment is coming down into it, and there's probably some erosion going on. It just captures all the sediment, and it's just like a little sediment chute, and everything is pointing down towards that main canyon floor, which is quite a few hundreds meters below us now. So now we're dropping down into that the chute of that gully, and we've got halosaurs and shrimp. Seems to be the dominant demersal life. Oh boy! Hey, look at there's a coarse. This sediment here looks quite coarse. We've got Marty. Are you checking this out? All right. So
I can get a little closer once we get to it.
Yeah, thank you. That would be good. We're still on our transect, aren't we?
Yeah.
Yeah, so we can't actually stop, but this is really interesting. So it definitely has a coarseness about it. And now if I was to put money on it, I would say this is probably coarse coral, like shallow water coral, pieces of literally the shallow coral reef, which is lying higher up above us. And it's being directed into the chute at the bottom of a creek. Just a land analogy here. and then we're climbing out of that chute up the side of this next gully. And yeah, like a really interesting environment. Yeah, and Dougal's just pointed out the lack of holothurians, and it's a good point. I mean, this is a muddy, sandy environment. In other, like yesterday's dive, we were deeper. It was more muddy and it was more flat. The gradient was much flatter, and there were lots of sea cucumbers. Haven't seen so many on these sidewalls, but plenty of eels and shrimp. Yeah, so these are like valleys. Think of them as smaller ones. We're just calling them gullies here. So the gully drains into the larger valley, the valley being the main trunk channel of the canyon. The canyon's a much bigger beast. It's like 10 kilometres long. It's about 1 to 2 kilometres wide at its widest. As you get closer to the Great Barrier Reef, it gets narrower and steeper, and we're in the middle section of that 10 kilometre long canyon, and it's clearly V-shaped, and we're going up the sidewalls. Oh, it's a really nice sea star here. Quite a good size, so you can see the. Oh, and we got it looks like a tulip sponge off just crossing through on the left of the screen. So big sea star. In fact, there's the imprint of one. You just make out the 5-star imprint of the sea stars. So just pointing out the laser beams in the centre, they're 10 centimetres apart, so that gives you a sense of scale. So that one we passed was probably a good 20 centimetres across. Another shrimp. Oh, what have we got here on the... There's something just to the left of us. Oh, is this a squid? It's a squid.
We can't stop though.
You can't stop, unfortunately. I might just quite... Yeah. Oh, this beautiful squid. We're in the middle of a transect here, so we really can't hang around, but we have this beautiful squid just sitting here. You can see his arms pointing towards us, and it's got a lovely extended fins at the back of him. We have to keep moving, unfortunately.
Rules are rules.
Rules are rules, yes. We are on this transect. We have to do this. This is part of the systematic comparison that we're doing between each of the ROV dives. But not to worry, we will see more of these. We'll see when we go out in the Coral Sea, where we've been quite fortunate. We've seen lots of nautilus, squid, Dumbo octopus, pygmy Dumbo octopus or squid. You know, there's quite a lot of cephalopods out there in the Coral Sea. So, but for my money, I think that was our first. Was that our first cephalopod on the GBR margin, Marty? Is that our first one? Yep, that was our first cephalopod in the deep GBR here. So that was great to see.
And rules being rules, if we do see a Dumbo, we are stopping.
Oh yeah, okay. Chris is saying we stop for Dumbo octopus. Yeah, I have to agree with that. Yeah. So I was on the last expedition doing it virtually from my home in Cairns, and it was quite funny to be tracking along, and suddenly you hear the the pilots going Dumbo, Dumbo, you know, like it's like so cool, you know. And if anyone was watching, it was just spectacular. It came drifting out of the left and it went right in front of us with its really strange flapping ears, just looking like Dumbo the elephant. And yeah, just fantastic. So we stopped for Dumbos. We also stopped for Nautilus, I might add. There are Nautilus off the edge of the Great Barrier Reef, and our colleague Andy Dunstan, who did his PhD on Nautilus, was teamed up with colleagues from America, Greg Barrord from the USA, and they brought a team of people out to the Great Barrier Reef, very close to where we are now, and they put a whole series of BRUVs, baited remote underwater video systems. They're basically cages with video cameras inside, and lowered them down off the edge of the Ribbon Reefs, right, very close to where we are now, in about 200-300 metres of water, and there's no surprise they actually found lots and lots of Nautilus. So I think this is too deep for them at the moment. Out in the Coral Sea, we typically find them between 500 and 700 metres depth. So we're in 1,200 metres of water now, so it's a little too deep for Nautilus. Oh, it looks like a xenophyophore. Did you see that? Just passing by. Monothallic, can never say it. A xenophyophore. It's a form of. It's a benthic foram. They form these very large tests that are about baseball size. We have seen them out in the Coral Sea. You find them in organically rich environments, and this is exactly what we've got here. Lots of food. There's another one just passing under us. There's these little lumps on the seafloor. And here we got a sea cucumber coming up. Is this a squid off on the... I think we've got another squid just passing us on the right-hand side. Yeah. Yeah, it looked like a squid. Anyway, there we got some pink holothurians coming in. I think it was a squid.
I didn't see that. I just saw a little hole, the little burrow.
Okay.
Where the stuff deposit we saw, the tail from.
Yeah.
That's like one of those.
So plenty of eels, halosaurs, lots of Cynobranchus, thanks Dougal. Cynaphobranchus, sorry, get that right. And we're on this 500 metre transect, so we're continuing to move along fairly clip pace here. But now we're climbing up over the edge of one of these gullies. There's a shrimp just drifting past us. And this is the crest where the tops of two gullies join, and then we'll drop back down into the next one. But the idea is that we're actually crossing them diagonally and climbing up the slope. So we're now at 1,200 metres. And we're seeing some more of these burrows right in the crests there. And one of these deep water jellies drifting past. We actually collected one yesterday, sloped him up. And we got that pickled for Dougal. But look how steep these gullies are. You know, think of them almost like avalanche faces, but everything's going down. You know, so we're on the continental, more broadly, we're on the continental slope of the Great Barrier Reef, and everything's draining into this basin that's called the Queensland Trough, and that's about another 800 metres or so deeper down, where it starts to flatten out. Everything's being directed down there. Food particles, mud, rocks, dead animals, right? All organic matter is just this huge shelf to basin transport. And of course, it's no surprise these canyons are the main conduits of all that sediment and organic matter. Clearly, the marine life, they've evolved and adapted to take advantage of all this. Whatever's drifting down from above through the water column and also being washed down or falling down the sides of these gullies and into the main canyon below. But boy, I mean, look off into the distance. It's almost like looking at the edge of a mountainside. The successive ridges, almost like anyone who's been skiing would know what I'm talking about. You're looking at different ski faces. And this might be an avalanche face here, but these are ridges. They're all joined up, but they're all pointing downwards towards that main valley, which is the channel floor below. But it's just great to get this kind of perspective. Wowee! I mean, we're looking at 1, 2. You can count them. There's about 3, maybe even 4 gullies in parallel, each one joined to another. Each one have their own discrete catchment area. But little chutes, very well-defined chutes at the bottom of each one of these gullies.
Yes. All right. So we're just doing our 500s. Going along the line. Change the angle just a little bit just now because it's such a steep angle that.
Yeah, and have a look at some of these steeper faces of those gullies. You can see where it's fallen away, and there's some burrowing going on. So you haven't started to finish?
Yeah, it should be.
You want to pause transect real quick while we pause transect? Yeah.
Just fine, great.
So Steve's asking, how much these gullies sequester calcium carbonate from corals. So if you think of coral reefs, they're constantly growing, accreting and eroding, right? This is natural. So they're left alone, the corals will continue to grow, but through wave action and storm environment and bleaching events and like, they erode down. And so that sediment ends up somewhere. So some of the coarser sediment ends up closer into the lagoon itself, like a coral reef lagoon, the back reef lagoon, sort of classic coral morphological environment. And some of it ends up down here. So we have Ribbon Reef 5, which is about 4 kilometres due west of where we are now. And some of that coral rubble material rains down into this environment because the head of this canyon is in fact right at the very base of that Ribbon Reef 5. So part of the exercise here is to actually take some samples, and we've done 2 so far where we've basically taken those sediment samples, and they can tell us a lot about the material that's drifting down into these. And so we would expect this is a very high calcium carbonate content. Most of the sediment here is limestone. Of course, it's not just coming from coral, but also from the pelagic sediment that's raining down from the water column above, and that could simply just be pelagic plankton. There's lots of foraminifera and all kinds of finer shelled plankton. When they die, they just drift down, and they go to make up this sediment, and we call it hemipelagic. So it's pelagic, it's come from above, but I'd say a lot of the sediment here is also made up of shallow water corals. And now we know this for a fact because we've got some deep water cores from the base of these canyons, and when you split those cores open, you can see shallow water coral material in there. Now that doesn't grow there, it can only have been transported from the Great Barrier Reef. So think of these canyons like huge conduits, like the big rubbish collectors, and they're capturing all of this sediment material, both from the shallow water corals and also from the water column above. Just taking over. I'm Rob Beeman from James Cook University, and we've got Jeremy Horowitz, our black coral expert. I'm going to grab some lunch, and Jeremy will take over.
Yeah, it's something. Yeah, everyone in the control room, we are getting really good at spotting that one hello swordfish. So I can now name one fish. Pretty proud of that. So for lunch, we have smoked ham and garlic roasted potatoes and some fresh greens.
It was a kale and watermelon salad.
A kale and watermelon salad. And what was the pineapple?
It was
A cinnamon crusted pineapple.
roasted pineapple.
Yeah, really good. We eat pretty well on this ship. Yeah. And then there's also a compartment where you could find M&Ms that never end. So
Jeremy's tried to find the bottom.
yeah, I keep trying to get to the bottom, and it keeps every time you put them in the closet and close the door. Once you open it again, it's magically refilled. So it's this amazing process that we don't yet understand the underlying mechanisms, but we're getting there.
Their names are Mildred and Raquel. Cool.
So we're seeing some halosaurs. And some sand. Yeah, on these expeditions, there's always a magnificent chef. So this is the third research vessel that I've been on for, an extended period of time, for like a month or more. And every time I guess they must really make sure to have a really good chef who's just always cooking. And often people do shifts that mean someone's always working. So 24 hours, there needs to be food. So that means, there's always fresh food being made, food being put aside so you can have breakfast, lunch, or dinner most times of the day, and dessert all times.
Smoked meats.
Smoked meats. Yeah. So we're still doing our transect, is that right?
Yes.
Holothurian.
Completely different scenery now. It's all flat now.
Right.
Smooth vertical.
Right, so there's been a nice change as we're going up.
Got about 200 meters.
So we're at 1,155 meters. It's 4 degrees Celsius. Oh, there's a vase glass sponge, or tulip sponge. I think it's a tulip sponge. It's beautiful. We've already collected one of those, and we're going to try to minimize collecting the same species twice, or, no more than 5 times for sure. If you remember yesterday, when we were down at 1,800 meters, the temperature was like 2 degrees, and so now it's 4.2 degrees. So, from about 2,000 to about 1,000, the increase in temperature is about 1.5 degrees. Ah, yes. There was a gorgeous blue sea cucumber. We just passed it. So, one of the reasons, so you may wonder why there's sediment, on this vertical slope. And so it could be an indication of a lack of downward current, of downslope current. Another Helthurian. This one seems to be floating just off the seafloor. Or is that something else? I don't know. Yeah, can't stop. We're in the middle of our transect, but it was cool. Yeah, it's really surprising to be seeing this mud and substrate and debris settled on this slope. It'll be really interesting to understand the process. Why is it not falling down? Why is it where it is?
You're gonna want one?
Nah, you're gonna drop it down.
Got one.
How many of those have you done in your life?
So many. So good. Joe,
Yep.
how many expeditions have you been on?
Been on 3 expeditions. I was on ROV Alice, which is from New Caledonia,
Yeah.
but it's a French ship. And then I was on the Investigator last year, in the same general location as we are now.
You're dredging?
Yeah, dredging. 55 dredges, 150 corals, 0 black corals.
Oh wow. None.
And that was the only reason why I was on the ship, was to get some black corals. And
Oh no.
it was the big joke of the trip. Luckily, there are obviously lots of black corals around. It's just,
Yeah.
just the luck of the dredge.
Deep.
Yeah, really deep, like 4,000.
Okay.
Yeah, thanks for helping identify that critter earlier, whether it was a holothurian or not. I think it might have been a comb jelly dougal. A big one. But there are lots of holothurians. There's another. This one seems to be rolling in the sands, having a grand old time.
Go 308. I'll pick it up to you then. One day. One day I'll catch it.
How many dives have you guys done?
379.
Really? Wow.
I was gonna say, I don't know how many expeditions I've been on.
Thousands. And they still let you drive, huh?
No. They won't even let me drive at night.
They won't. Why?
Say I almost killed them.
All right. Well, that's a.
You've
Just
taken me
a
to
fact.
that airport in Portland. We missed the exit 3 times. So the old lady in front of us. I had to pull him over and be like, alright, I'll drive.
You don't say turn right in the last minute.
I did. I said 3 lights, turn right. He said, okay. Light 1, light 2, 3, 4, 5, 6. You turn right. You remember that? And that was a straightaway. It was right after, right when you got out the dry dock. You know that straightaway, huh, buddy? You got that 7-Eleven on the left?
Ooh.
Take it right. Did.
We got glass sponges.
Like those people in the UK drive from the M25.
Yeah.
Because they miss one exit, they go all the way around from each other.
Same measure.
Glass sponge. Okay, so if Ben ever offers to drive you somewhere, just say no.
I do driving, but for driving
I agree, actually. I don't like driving at night either.
deep.
After this, I have to drive from Brisbane back up to Townsville. That'll be a 3-day drive with some breaks. But I'll only drive in the daylight, early morning till about 4 or 5. And
3-day drive.
I mean, it's what is it, a 15-hour drive, maybe 16-hour drive.
Is it a scenic route? Like, is it pretty or is it
Sure,
just flat?
some of it. You're near the water. You know, it's along the coast. You haven't been to Brisbane?
Yeah, we're in Brisbane. But we didn't travel.
Right.
Didn't travel.
Yeah.
The Gold Coast.
How do you become an ROV pilot? There was a question. Ooh, look at this.
Dumbo.
Dumbo.
Wait a second.
Dumbo.
Can we pause and look at it?
All right, we're gonna pause. So this is a Dumbo octopus. This is the first time I'm ever seeing one in person, virtual person. So yeah, let's take some nice still. Oh, beautiful. Look at this.
So we got a marker where we stop the transect.
Yep.
We'll stay with him for about a few seconds just to get some nice shots.
Yeah. Let's try to get a nice focused view. So it's about 18 centimeters across. Look at this guy. I'll just try to get a sharp shot of him. Look at his eyes. They're very Disney-like, aren't they?
Yeah.
I guess that's why they call it the Dumbo. All right, some sediment kicking up. Yeah, we're pausing our transect, which this is the first time we're pausing our transects for anything, so you know it's important. You can see the eye's got that little white outline, big black eye. Beautiful. And you can see how the eye closed as the sediment went towards it.
Oh, just got tapped my sunglasses. Aren't they? Shouldn't have bought them up.
Yeah. Okay. We're good? Yeah. All right. Back to our pre-programmed transect.
That was a question, how does someone become an ROV pilot?
Yeah. They can hear you, right? From there? Or?
A-type personality. Not get seasick.
So I'll do is I'll give them a translate and I'll answer it.
Yeah.
A bit more. How do you want to be in that?
I'll start right there. I'll give them a little extra. Alright, there we go. And begin transect.
Begin transect.
Back on it.
Is that as far as can zoom out, Jamie?
No. Yes. Right? I've never seen one before. I've seen them.
We had a couple on the last Coral Sea voyage, and it was something. Just kind of drifts in the view that those beautiful, strange flapping ears.
The eyes. Big, vacant, black eyes.
Yeah. But I don't know if you caught it. Just before you took over, I was saying we're on a 500 metre transect, right? We have to stop and continue. And then the pilots go, yeah, but we stopped for Dumbos. Yeah. Of course we stopped for Dumbos. And there we are.
That's funny.
Yeah.
That's funny.
Yeah. Because we also stopped for Nautilus. But it's a bit deep here for Nautilus. It's about 1,000 metres now. We're a kilometre deep. And we do find them in depths around that sort of 500 to 700 metre mark in daytime. At night time it's different. They vertically migrate, go up into the higher in the water column to around 200-300 metres.
Rachel's made about Nichol.
So we will probably stop for Nautilus as well. We may get an opportunity on our next dive. That's this afternoon. So the conclusion of this dive 379, we will recover the ROV, and we will move about 3 kilometres further west of where we are now, closer to Ribbon Reef 5, and then we will put the ROV back in the water. We're expecting depths anywhere between maybe 300-400 metres, and then we'll climb up the side of the head of this canyon. We're at the it'll be the very western limit of it. It's just exactly where it sits, close to Ribbon Reef 5. So just to repeat that geography, we've got Ribbon Reef 5. It's an outer barrier reef on the Great Barrier Reef, and you could scuba dive on it and snorkel, and I've been there, and it's quite a lovely coral reef. And on the seaward side of it, it drops quite steeply to a shelf break around about 90 metres depth, and then we have basically a big vertical wall, and that is the head of this canyon that we're in at the moment. And so the idea is we'll recover the ROV, mobilise west, and probably around about sort of 2-3 p.m. in the afternoon, we will put the ROV back in the water and climb up the head of this canyon. So these are sort of softball-sized balls on the seafloor. Xenophyrophores. They're a foraminifera, and quite fragile. If you were to pick them up, they can crumble quite easily, but they have this really complex skeleton that basically, it's called a test, foraminiferan test. And like you mentioned, they're a single-celled animal, and they have cytoplasm. Just trying to recall my undergrad biology here. I'm actually a marine geologist, but they create these very complex, fairly large tests. You could easily pick it up in your hand, but they typically form in deep ocean environments with high organic matter. And I think you can all agree it's pretty. There is a lot of organic matter here. We're seeing lots of burrows. We're seeing lots of sea cucumber fecal pellets, sea cucumber poop on the seafloor. No, there's plenty of food and organic matter down here, and we're literally only about 4 kilometres away from the edge of the Great Barrier Reef here, so it's pretty close. That's right, Dougal xenophyrophore.
We've collected quite a few of them.
Yeah.
With the arms.
Yeah, okay. Yeah, pilots are just saying they've collected quite a few of them in the past. They're pretty fragile though, aren't they?
Very, very fragile.
Yeah, you can easily crush them. So there's one just passing by on the right-hand side of the screen now.
Collected them, Greg. What's Greg's last name? They Falkor. They didn't Falkor. Yeah.
Purple socks.
And the Trabellas.
Is it just the filter for Kappa slot, or is it the whole white alpha? Because there's one that's like a top side.
Yeah, so just talking about organic matter, you can see these little almost toothpaste-like tubes on the seafloor. These are very likely from holothurians, right? We have seen quite a number today. We certainly saw lots yesterday in dive 378, lots of sea cucumbers. It's a bit deeper, about 1,800 metres. And we call them vacuum cleaners of the sea. They're basically slurping up all this mud. I do a lot of scuba diving on the Great Barrier Reef myself.
That's and a transect there?
You do see lots of sea cucumbers in the shallow parts of the Great Barrier Reef.
Core?
Lots of different colours. Down here, though, we're seeing about 3 or 4 different types of sea cucumber, including a really spectacular purple one at the very early start of the dive. There we go, one of these purple ones. But if you recall, it was just floating in the middle of one of the canyon in the mid-water, like it was asleep. It was quite a amazing looking sea cucumber. Here we go. I'm just probably glad I'm not driving the ROV. I'm just trying to manipulate the view here with my little joystick. There we go. It's a good view. We're just finishing the 500 metre transect here. So that's important because we're doing a systematic comparison between all the different canyons that we're studying. And something else that's really interesting, if you look below the sea cucumber, there's a parallel, there's a linear line of burrows. Now, what is causing that? I don't know, but we're certainly open to suggestions here. And looks like we got a halosaur just off to the left. It doesn't seem to be too bothered by us. Rat tail, thanks Dougal. Told you my fish ID is not so good. We really appreciate people's input from ashore who are helping us ID these animals. Yeah, rat tail. You can see its pectoral fin sitting up. Quite a deep body compared to some of the eels that we've seen earlier. And this is also part of the systematic survey. We take a push core at the end of the transect, so we're doing that now. We collected one at the beginning. We also collected one at the very bottom of the canyon floor. This is important because the sediments can tell us, the analysing the sediments can tell us a lot. The origin, the provenance of these sediments. What originally made them? Was it coral? Was it pelagic plankton? How much quartz is in it? How much carbonate? Calcium carbonate is in it. Just all of this analysis you can do just from taking a plug of sediment.
That's all. Yeah. I'm going to stick it perpendicular to the...
And thank you to Noonie on YouTube, just helping us explain allosaurs. I'll just read it out. The rat tails have stouter bodies, distinctive dorsal fin, and along with very big eyes and a non-forked tail. Yep, that would describe that one really well.
It's falling already.
Yeah, okay.
Drop that one and try and... So we lost it?
No, it's not.
Oh, I see. Yeah.
Oh, okay.
I'm going to go up a little hard then.
There we go.
You can just get a sense how soft this mud is. You know, you could plunge your arm into it quite easily. I was out here in 2017 on the new Sonne. It's the big German research ship, one of the largest research ships in the world. We were out here with Maya Tardi from MARIM, the German Research Institute. He's a paleoceanographer, and we were plunging 8-metre cores into this area. We worked out here for a month, and quite a great experience being on huge German research ship. But we were collecting these great long piston cores, and so much longer than these push cores. And it's almost like a big factory on the back deck. You would plunge these great long cores into the seafloor, and you pull out this great huge long plug of sediment, and then it'd be laid on a big table, and then everyone would get to work taking samples from it. And the idea was to look at the oceanographic signals that were locked up in the sediments. So think of these sediments like layers of history, and of course the deeper you go down in the core, the older it gets, until you get to the modern sea surface, which is present day environment. So the longer that core can be, the further back in time you go, and this can all be age dated through radiocarbon age dating and other techniques. But with each layer, when you split these cores open, you can see them. They're just very much like looking at tree rings. So this is a really valuable way to understand our oceans. And there's a very large, world's largest marine geological program is the Integrated Ocean Drilling Program. And there's scientists who devote their entire lives travelling around the globe, taking very, very long cores out of the sediment to try and understand the oceanography, marine life, the geology of the seafloor, and it's been running for many, many decades. Australia is a part of the IODP through the ANZIC community, which is Australian, New Zealand, ANZIC, Australian and New Zealand IODP International Consortium. So it's all to do with the integrated consortium, all to do with being part of the IODP global program. Yep, good collection. Yep, thanks very much. Yep, so we're after some replicates. Oh, we've just disturbed that sea cucumber. I was thinking something's going on. We're just taking a few holes away around from where it's living, and because one of their escape mechanism is to kind of throw themselves up into the water column. There we go. And off we go. That's just brilliant. Yes, and we've seen plenty of these swimming sea cucumbers. Fantastic. Funny, it waited until right at the end before it took off. And
keep longer. Yeah, keep on going up. We've got half an hour, haven't we? Yeah, 20 minutes. Okay. 20 minutes. Thank you.
So we're just climbing up the northern side wall of the main canyon. This is canyon directly in front of Ribbon Reef 5. Ribbon Reef 5 is about 4 kilometres west of where we are now. So we're just climbing up the steeper side walls. The beginning part of this dive was really steep. Vertical walls of rock closer to the channel axis itself. We've climbed over that, and we're now into these sort of fairly steep gradient but softer sediments, and we're seeing lots of Lebenspuren, life traces, burrows, mounds, tracks, and the sorts of animals we're finding here is dominated by, well, now sea cucumbers. We've seen quite a few crustaceans, shrimp. We did see a really spectacular lobster or crayfish. I mean, really quite a large size. I've never seen one like that before. But yeah, we're definitely in sea cucumber country now. And of course, lots of eels. Eels, halosaurs, rat tails. There's certainly a lot of fish life down here. Here we are. There's one having a good look at us.
No.
Yeah, look at that face. Yeah, thanks, gents. That's good. Good driving. So we're at about 1 kilometre deep, 1,030 metres. Temperature's still pretty chilly. It's 4.4 degrees C. Down here we're still within the Antarctic intermediate water. This is this lower, colder water mass that's following the topography, and it's formed south in the Southern Ocean, and it drifts. It basically moves towards the equator. This is really amazing. Look, downward facing. Is this a rat tail? Yeah, rat tail. Let's get a really good look at that one. See if we can zoom in. Whoop, sorry. Just as well I'm not driving the ROV. I'm just playing with the zoom controls here. I'll zoom out a bit. Of course, any time we stop, we're really throwing up all this sediment, and that's unavoidable. Unfortunately, it's pretty muddy here. Anyway, so anyone in the fish army, they get a good look at that. Okay, we got people saying possible cusk eel. That's good. Yeah, we appreciate the help from ashore.
We're recovering in 20 minutes. All right. 100,000 meters, so. All right.
You want to jump in for a bit?
You want one break?
I'm all right.
We said text them when we recover. You're looking for a rock, huh?
Wow, yeah. Probably won't get one now.
Yeah, I doubt.
I think there might be one to the right.
Yeah. What are you looking? You're looking at the forward-looking sonar for that. So we've got about 20 minutes or so before we're going to have to terminate this dive and recover the ROV. But the fun's not over yet. We're going to once it's recovered, we're going to reposition the Falkor about 3 kilometres west of where we are now, and that'll be a little bit closer to Ribbon Reef 5. higher up the canyon and closer to the head of this canyon. So we'll expect to see the environment change again. It's certainly going to be shallower. We'll probably get into the mesophotic zone. It's an area of great interest to us, both geologically and biologically. We have some ideas about what might be there, but as we're finding, there's also lots of surprises. So what we'd like to see geologically is exposed strata. So literally the deeper roots of the Great Barrier Reef, where they're exposed on these steep rock walls. We'd like to see that, going from perhaps not these really old looking rocks that we've seen earlier in this dive, but something more like layers of coral reef, right? And this gets back to the story about the origin of the Great Barrier Reef. And, we have this deep, long core that has been taken through the middle of Ribbon Reef 5 back in 1995. And Jody Webster, who was our colleague on this voyage, unfortunately he's at home in Sydney, but I know he's watching. He's particularly interested in this because he's been involved with this core. It was part of his PhD when he was an undergraduate, when he was a postgraduate at the University of Sydney. And people have been studying this very long core. It's about 200 metres long for many years, to try and get a sense of when the Great Barrier Reef started. And at this stage, our best understanding is that we might be talking about a Great Barrier Reef origin that transitioned into this sort of tropical carbonate coral environment anywhere between, say about 600,000 years ago. So Great Barrier Reef is relatively young in geological terms. So it was only until that time, say 600,000 years ago, that the shelf was perfectly formed with the right width in the right climate zone, the right temperature, the right water quality. That coral reef started to develop. So this very long Ribbon Reef 5 course, about 200 metres long, actually pushes through a whole lot of cycles. Every time the sea level dropped, coral reefs were exposed, and then as the sea level rose again, coral reef would grow. And so we have these cycles, 6 to 8 different cycles since the beginning of the Great Barrier Reef's origin. So Dougal, what have we got here? Is this a Medusa? It seems very solid to me. Looks like it's a jelly of some kind. Looks like one of those upside down jellyfish you find on the Great Barrier Reef, but you wouldn't think one down here. What have we got here, Dougal? For those of you who aren't aware, Dougal Lindsay's our resident plankton specialist, but he's in Japan. So he's been joining us. We've been doing these Dougal dives.
Sea squirt.
Sea squirt? Yeah, tunicate perhaps? Yeah. Yes, a mysterious blob. Yeah, we don't know it all, and I think that's pretty cool actually. There's plenty of animals here we just go, what the heck? You do a mental search through your phylum list and you come up blank. Thank you. Tunicate bigmouth. Wow, okay. That's first time seeing anything like that. Yeah, it looked like a Medusa was upside down and pushing into the seafloor, but no sampling at the moment. Unfortunately, we are getting very close to the end of our dive, probably about another 15 minutes, and then we're going to have to call it quits. We have to recover. We've got to recover through, a kilometre. So it takes time.
It's starting. All right.
Hey, there we go. But yeah, the aim is to do sampling. This expedition, we have permits both in the Great Barrier Reef Marine Park and in the Coral Sea Marine Park, which adjoins it. And we have a lot of interest from biologists from all around the world. We're particularly interested in corals, so soft corals, hard corals, sponges, other invertebrates, and plankton. So, and of course, all the sediments and rocks as well. So, this is a very much a focus of this expedition, is to collect samples. But right now, unless something really amazing just jumps out at us, we will continue along for another 15 minutes or so, and then we will. We'll complete the dive and recover, but then the aim is to move westward, and in about an hour or so we will put it back down. So we'll have a second dive this afternoon.
On the bottom, 3:30.
Yeah, aiming for back on the bottom around 3:30. So in about 2 to 3 hours, about 2 hours away, we'll be back down on the bottom. Yep, photo bombing shrimp. Yep. Yeah, so the eel thing, we've seen a number of fish down here. The fish tend to be these long eel-like animals, but it's a couple of eels we've seen. These could be grey cutthroat eels. There's also probably basket eels. This is a
coral.
Little cup coral.
Is that a cup coral? Florbellum or whatever it's called? Little florbellum? Not sure. Salt cup coral?
Jeremy, there's another one of those things.
Oh.
Just there. There.
Want to zoom in on that? Do we have time or?
Yeah. Just having a bit of a look here. This is a cup coral, and just to the left of it, in the center of the screen, this really. Whoops, sorry. Just turning. This is me driving the the camera.
It takes a little practice.
Yeah.
You can zoom in.
Yeah, it's quite strange. We saw some on a boulder, a soft sediment boulder, a bit of debris from yesterday, and we do not know what it is. And you can see it's stalk-like. It's quite small. It's only maybe 2 centimeters tall. And it's on this stalk, and it has this flat, like about the size of a fingernail, flat area, and then it has these almost tentacle-like pods on the outside, and we have no idea what this is.
It has a real intricate root system. So we scooped it up out of the mud, and when we cleaned it off, it's really extensive root system, and this little circular head with whatever tentacles around the circle.
But it's a fringe, right? So it's completely laterally flat. It's not like a ball of tentacles but it's quite a strange looking structure.
It's interesting to see it just here in the middle. Tube worm, Nichol says.
Not so sure. Yeah, that's all right. Good try.
We have a good picture of it. Dougal, I'll send you a picture later. We can head out. We can continue.
All right.
That coral?
No. We'll just keep trucking along and see what we can see. And because we have these, these are some xeno. Whoop, sorry, I'll just zoom out. Sorry, everybody. It's just me driving. We'll go zooming out. If my son was here, he'd be able to drive this no problems at all. He's. I'm just an old guy, and the technology is a little overly responsive.
Yeah, it's very sensitive.
Yeah, I agree. Great forams. Yeah, I like looking at them too. We haven't collected any. Oh, there's a nice ctenophore drifting past. There's one for you there, Dougal. Yeah, they're really amazing looking, these xenophyrophores. And I mentioned before, they're found in organic rich environments in the deep sea. When we go out to Osprey Reef, which is one of our destinations, we should see them there as well. On a previous ROV dive and the Visioning the Coral Sea expedition, we saw lots and lots of these xenophyrophores together, really clustered deeply in on the seafloor. But here they are again, and off we go. Yeah, I totally agree with get all the kids driving these things. They're just so much better at it. But I got to say, the ROV team is just fantastic. Just what they can do. Because it takes a lot of concentration. We have a full team here, and they take turnabouts every hour, couple of hours or so, because it just it takes a lot of concentration. We are talking about an ROV that's the size of a large car. It's a kilometre underneath us, and we have to do this delicate dance between the ROV and the ship above. Oh, what's this? Is this a siphonophore? Oh, this is really beautiful. Okay. There's another one for you there, Dougal. Or hydrozoan. Yep, Dougal, you'll pick this up pretty shortly. It's got these colonial, maybe colonial hydrozoan. You can see how they... So Dougal is in Japan, and unfortunately couldn't actually join us physically on the ship here because of all the difficulties with international transport getting into Australia. So, we had to come up with other ways, and because him coming in remotely and talking about the midwater dives has been really good. And possibly another hermit crab. Let's continue along. So I tell you, we're getting near the end of the dive. For me, the highlight has been seeing the rock, right? Seeing that strata rock. We're talking ancient, hard rock basement. That this is what the Great Barrier Reef is growing upon. That, for me, geologically, that was the highlight.
I think some might say the Dumbo octopus is the highlight.
I don't know. What do you think? Ancient rock strata versus Dumbo octopus.
Fundamental increase in our understanding of the Great Barrier Reef, or a charismatic critter
with cute eyes. I don't know. The cute eyes will always win.
Googly eyes on rock sample.
Dumbo octopus wins. Yeah, rocks. Yeah, go Emily. Cool. Actually, I thought the gullies were really interesting because we actually had mapped them. We knew that they would be there, but actually see them live, that kind of, parallel ridges one after another. That was really fascinating. Now, those gullies are what's draining most of the sediment into the main valley. There we go. The cliff was awesome, I agree. And also what's growing on the cliff, because we have Jeremy, our black coral expert here, and most of the sessile fauna, the corals and the things like, they're attached to those exposed rocks, and the rocks are exposed because they're just simply so steep. The sediment doesn't build up, and so you get these nice clean faces and lots of things growing on them. But I still love going across these sandy environments, these muddy environments, because there's plenty of life there. You can see it because they've left a trail behind, and you don't get that on rocks. So, you can see the burrows and the tracks and all the holothurian poop. You can see these little twisty toothpaste tubes on the seafloor. So clearly lots and lots of life down here. But, it's quite easy then to make these broad statements, the different kinds of habitats. So we have these steep rock exposed walls, and they have lots of soft coral, lots of corals, different kinds of anthozoans, we saw corallimorphs early. They were really quite strange looking.
Pink river sponge.
Yeah, and feather stars attached. And then we're in this soft sediment environment, and we're seeing lots of eels, sea cucumbers, and we got lots of shrimp. Shrimp seem to be everywhere. They're in both environments. But yeah, we're lots of eels and rat tails. There seem to be more fish on the soft sediment than on the hard rock environment. Would you agree, Jeremy?
So they must be feeding with other living things in the sand and the mud.
Yeah, that's right. And there's a xenophyrophore on the right. So at James Cook University, where I work, there's a very large.
You're going to be recovering the ROV in a couple of minutes?
Roger.
Okay, copy that.
There's a very large fish study group led by Marcus Sheaves. He's a professor of marine biology there. And I was just explaining to Marcus just how many eels we find down here. And, you know, it's great to bring these other experts in because they think different ways than I might. They straight away they're asking questions like, well, what's their energy source? What are they eating? Now, we haven't seen them eat anything yet, but there must be a lot of food down here to support this much biomass, right? So what are they eating? Is it the shrimp that we're seeing? There's plenty of shrimp there, and that's a fairly big. Oh, there's a little squid. Oh yeah, a little. Oh,
You can see its belly.
that is so cool. Look at it. Aren't we lucky, eh? This is right at the end of the dive.
Yeah, last highlight.
Oh my God, that is just. Oh, look at that. Completely translucent. So squid has got a pen. It's a semi-rigid skeleton. It's quite reduced. And you can just make it out in the middle of it. It's giving that rigid structure. Yeah, totally. And it's got its arms upright. Oh boy. And look at that, you got just the most translucent little fins at the back. It's pretty tricky. It's not very big. It's probably only a few centimetres across. All right, I think that's a good way to finish it. Yeah, there we go. Squid, take a bow. Thank you. And there we go. All right. Well, thank you very much, everybody. That was just terrific. And so the aim is we will recover SuBastian. We'll bring him back on board. We will mobilise transit about 3 kilometres west of where we are, a little bit closer to the Great Barrier Reef. And in a few hours, we will put SuBastian back in the water. So if you can hang around for a few more hours, we'll get another look at this canyon. It will be a
rough estimate when it will be once on the surface.
30-40 minutes.
Yeah, so we'll recover about 30-40 minutes.
30-40 minutes, thank you.
Yeah, and about an hour or two we will be back in the water. So the aim is to get shallower. We're going to look at the mesophotic zone, or as far as we can go while we have daylight. And we'll be climbing up to the head of this canyon. The head of the canyon is directly adjacent to Ribbon Reef number 5. So if you can stick around a few more hours, we'll see you again.
That's a wrap. Hold on.